Hello everyone, this is Aishwarya, working as an assistant professor in the Department of CSC AIML, MLR Institute of Technology. Today I am going to explain about the data cleaning and approaches in data cleaning. So first of all, we need to about the data pre-processing. So the definition of data pre-processing is it is a process of transforming raw data into an understandable format. It is also an important step in data mining as we cannot work with the raw data. The quality of data should be checked before applying machine learning or deep learning or data mining algorithms. So, the major task in data mining. In last class, we discussed about the definitions of data cleaning, data integration, data reduction and data transformation. Today, I am going to explain about the data cleaning. What are the steps we need to follow the data cleaning? First of all, we need to about the data cleaning definition. It is a process of identifying and correcting errors or inconsistencies in the data set. This is known as data cleaning. It involves handling missing values, removing duplicates and correcting incorrect or outlier data to ensure the data set is accurate and reliable. Clean data is essential for effective analysis as it improves the data quality of results and enhances the performance of data models. The main approaches in data cleaning are, first one is the missing data. How to handle the missing data? We need to follow some steps. First step is ignoring the tuple. Second one is fill in the missing value manually. Third one is use a global constant to fill in the missing value. Use the attribute mean to fill in the missing value. Use the attribute mean for all samples belong to the same class as a given tuple. Last one is use the most probable value to fill in the missing value. So first one is ignore the tuple. It means that skipping or removing the entire row from the data set if it has missing values. It is mainly usually done when the class label or output value is missing. It works with only if there are few missing values in the data set. It is not a good idea when many attributes have missing values or when different attributes have different amounts of missing data, because it can lead to the loss of important information. For example, if one student marks record is missing, the final grade, we can ignore the student data. But if many students record are incomplete, ignoring them, it would give wrong results. This is about ignoring the tuple. Second one is fill in the missing values manually. So for example, in this table we are having three columns. First one is a student, second one is subject and third one is a marks. Here student B's marks are empty. So this is a missing value. How can we replace it? So fill in the missing value in manually. So here student B's marks are missing. We can manually fill it by checking original records or using our own judgment. This method takes a lot of time and it is not practical when the data set is very huge or large, has many missing values, because checking and handling each missing value becomes slow and different. Third one is use a global constant. Global constant means what? For example, NA not applicable and R unknown. We can replace the missing value with these two global constants. So in this table, there are two columns. First one is the name and second one is the city. So in this table, the city column has some missing values. The city columns has some missing values. To fill them, we replace the blanks with unknown global constant. But this can create a problem. When a data mining or machine learning program analyzes this table, it might think there are two people, B and C, from a city called unknown. City called unknown. It is wrong because unknown is not a city. It means that data was missing. So the program could form false patterns or conclusions. So fourth one is use the attribute mean to fill in the missing value. In the missing value, we can replace with attribute mean value. So in this table, we are having two columns. First one is a person and second one is a income. So in the above table, the income value for the C person is missing. So and it is replaced by the average of remaining persons' incomes. So average is 25,000 plus 30,000 plus 29,000 plus 26,000 by 5. So the average income is 27,500. So this value is replaced with missing. This value is replaced in the missing value. So it makes the data set is completed without removing any data. This process is simple and common method used for numeric attributes only. So fifth one is use the attribute mean for all samples belonging in the same class as a given tuple. For example, in this table, we are having three columns. First one is a customer, second one is a credit risk, third one is the income. So in the income column, C is missing and D is missing. So for example, if classifying customers according to the credit risk, it is the missing value is replaced with average income of the same category. That means that, so C credit risk is low category. So we need to calculate the average of A and E. So A plus E by 2. So what is the income of A person? So 20,000 plus E value 10,000 by 2. So 15,000. 15,000 is replaced in the C person's income. The same as we need to calculate the D person income also. Instead of using the overall mean, for all the customers we use the mean specific to each credit risk type. This method gives a more accurate and realistic value because it considers that customers in different credit risk categories usually have different income ranges. Sixth one is use the most probable value to fill in the missing values. In this method, instead of using the mean or constant, we predict the missing value using other attributes in the data set. We can use tools like decision tree or Bayesian belief network or Bayesian methods to find the most likely probable value for the missing data. So the missing value is not guessed randomly but predicted based on the patterns in the data. So second approach is how to handle noise data. So noisy means what? It means random error or variance in a measured variable. It refers to irrelevant or incorrect data that is difficult for machines to interpret. It is caused by errors in data collection or data entry. It can be handled in several ways. First method is a binning method. Second method is outlier analysis. Third method is a regression. So first method is binning method. So what is binning method? It involves dividing a continuous variables into a set of smaller bins. It divides a smaller bins or smaller parts and replacing the original values with the corresponding bin labels. So in this binning method, we are following 3 steps. First step is a partition into equal frequency bins. Second step is smoothing by bin means. Third step is smoothing by bin boundaries. So, for example, this is a data set. So, 6, 10, 17, 22, 22, 25, 27, 30 and 36. Total 12 values are there. So, first step is partition into equal bins. So, we need to divide into 3 values in the separate bins. So, bin 1 is a 3 values, 6, 10, 17. Bin 2 is a 3 values, 22, 22, 25. Bin 3 is a 27, 30, 36. So, bin value equal to 3. So, second step is a smoothing by bin means. So, here each value in a bin is replaced by the mean value of the bin. So, mean value is bin 1 mean value is 11. So, 11 is replaced with original value. So, 6 is replaced with 11, 10 is replaced with 11, 17 is replaced with 11. So, same bin 2 also and bin 3 also. So, smoothing by bin boundaries. Here, the minimum and maximum values in a given bin are identified as the bin boundaries. Here, minimum and maximum values we need to consider as boundary values. So, in the previous slide, so here boundary value is 10. 6 is the minimum value, 17 is the maximum value. So, the minimum and maximum values in a given bin are identified as the bin boundaries. So, 6 is the minimum boundary. So, 6 is replaced with 6 also. Again, 10 is replaced with 6. So, maximum boundary is 17. Next, 22 is replaced with 22. Again, 22 is replaced with 22. So, 25 is a maximum boundary. In the bin 3, 27 is the minimum, 36 is the maximum. So, which one is near to 30? So, 27 is near to 30. So, 27 is replaced, 27 is replaced with 27, 30 is replaced with 27. Again, maximum boundary is 36. So, in this way, we need to do the binning method. So, second step is outlier analysis. It can be detected by the cluster values that fall outside of the set of clusters is outlier. This technique helps remove noisy and improve the data quality. So, third step is regression. It predicts the numeric values by modeling the relation between a dependent variable and one or more independent variable. The relation between dependent and one or more independent variables. So, linear regression involves finding the best line to fit two attributes so that one attribute can be used to predict the other. For example, based on the address attribute, we can predict the pin code attribute. So, multiple linear regression, it is an extension of linear regression where more than two attributes are involved and the data are fit to the multi-dimensional surveys. So, in this class, we discussed about data cleaning and approaches of data cleaning. So, steps to handle missing data and noisy data. Thank you.